Hello, AI enthusiasts. Imagine holding a tiny device in your hand, barely larger than a smartphone chip. And this unassuming little thing has the power to solve problems that even the world's most powerful supercomputers couldn't crack in millions of years. Sounds like a science fiction movie, but it's not. With Majorana 1, Microsoft has set a massive milestone in the world of quantum computing that will not only revolutionize technology, but perhaps our entire future. Like something from a Marvel movie. Only real. What exactly lies behind this groundbreaking chip? Why is everyone talking about it? And how could it change our lives, from self-healing materials to plastic-eating enzymes to solutions for climate change? Stay tuned, because today we're taking you on a journey deep into the world of quantum, exciting, entertaining, and full of breathtaking moments. The Majorana 1 is no ordinary computer chip. No, it's Microsoft's first quantum processor, based on a completely new and revolutionary technology. Topological superconductors. Sounds complicated, right? But at its core, it's a brilliant idea that changes everything. While classical computers work with bits, simple zeros and ones, quantum computers use so-called qubits. These qubits are true multi-talents. They can be 0, 1, or even both simultaneously, thanks to a phenomenon called superposition. This makes them incredibly powerful, but also extremely sensitive. Noise, temperature fluctuations, even the smallest external disturbances can throw them off balance and destroy their magic. This is where Majorana 1 comes into play. And it plays in a completely different league. Microsoft has achieved something that sounds almost like a magic trick. They've created a completely new form of matter, a so-called topological state. It's neither solid, liquid, nor gaseous, but something nature hadn't intended. Sounds crazy, right? And in this exotic state, live Majorana particles, tiny, mysterious quasi-particles that existed only in mathematicians' minds for over 100 years as pure theory. Now, Microsoft hasn't just discovered them, but literally tamed them. These particles are the key to stable, error-resistant qubits, and thus to a quantum computer that doesn't just impress in theory, but actually works and is scalable. Imagine a single chip no bigger than a fingernail, with the computing power of 1,000,000 qubits. For comparison, most current quantum computers only manage a few dozen qubits and need huge machines, sometimes the size of a football field. And the Majorana 1 fits comfortably in your hand. And the best part, these qubits aren't just numerous, but also incredibly robust. Thanks to the Majorana particles, they hardly need error correction, a problem that has kept quantum research in check for decades. How did they achieve this? With a fascinating mixture of indium arsenide and aluminum built with atomic precision, cooled to almost minus 273 degrees Celsius, near absolute zero, and controlled with precise magnetic fields. This is high-tech at a level that leaves you speechless. When I first heard this, I thought this is impossible. Microsoft's path to Majorana 1 wasn't a walk in the park, but a true marathon. The team researched, experimented, sometimes failed, and got up again for over 17 years. We spray the materials atom by atom, says Christos Vor, one of the brilliant minds behind the project at Microsoft. Each layer must be perfect, because even the smallest defect can destroy a qubit and nullify all the work. But all the effort, all the sleepless nights have paid off. Last year, they were able to make the Majorana particles visible for the first time, and this year they've finally gotten them under control. With microwaves, precise as a laser beam, they now measure quantum information that's so well hidden, it simply ignores even the wildest disturbances. The result is a chip that doesn't just shine in laboratory reports, but actually opens the door to a new era, an era where quantum computers are no longer dreams, but become reality. Why is all this so important? Because quantum computers can solve problems that are simply unreachable for classical machines. Imagine a supercomputer having to calculate the behavior of just 40 electrons. It would take longer than the age of the universe, even if all the world's computers worked together. A quantum computer with millions of qubits does it in minutes. And Majorana 1 is the first step on this path, a step that brings us closer to this future than we ever thought possible. Now it gets really exciting. What does this mean for all of us? Microsoft dreams big, and rightfully so. With the incredible computing power of Majorana 1, we could model nature down to the smallest detail and find solutions that sound like magic today, like something from Interstellar, just without the spaceship. Here are some examples that will blow your mind. Imagine your phone never showing a scratch again because the glass repairs itself, or airplane windows that automatically seal cracks before they become a problem. Majorana 1 could decipher the chemistry behind such self-healing wonder materials and bring them into our everyday lives. Plastic waste is a global drama. It accumulates in oceans, in our bodies, in huge landfills. There are already enzymes that break down plastic, but they're picky. and only work with certain types. With quantum computing, we could design enzymes that eat any type of plastic, from microplastics in the sea to packaging waste in the bin. Imagine we could understand diseases like cancer at the molecular level, down to the smallest detail, and design medications that work perfectly, without side effects. Majorana 1 could simulate chemical reactions that are impossible to calculate today and thus revolutionize medicine. Climate models are complex, imprecise, and often guesswork. With a quantum computer, we could accurately predict weather, better understand climate changes, and develop strategies against climate change faster and more effectively than ever before. And how about a battery you charge once and it lasts forever? Sounds crazy, right? But with the ability to design new materials, this could become reality for cars, phones, even entire cities. Okay, time for a little nerd digression. But don't worry, I'll keep it simple. Quantum computers work according to the rules of quantum mechanics, a field of physics so crazy it almost seems like magic. Normal bits are either 0 or 1, very simple. Qubits, however, can be both simultaneously, or even something in between. This is called superposition, and is the reason why they are so powerful. But these qubits are as temperamental as prima donnas. A breeze, a ray of light, and they lose their magic. That's why Microsoft brought in the Majorana particles. These particles are like little superheroes. They are their own antiparticles and hide quantum information so cleverly that they can barely be disturbed. This makes them more stable than anything the quantum world has seen before. And because they are so tiny, millions of them fit on a single chip. The control? Simple as a light switch, with voltage pulses instead of complicated tricks. You might think, sounds great, but isn't it just marketing hype? Not at all. Microsoft has published its results in Nature. Peer-reviewed and scientifically confirmed. They've developed a measurement method more precise than anything before. It can detect the difference between a billion and a billion plus one electron. That's like finding a drop of water in the ocean blindfolded. The current chip has 8 qubits, but the goal is 1,000,000. For this, they're building H-shaped structures from aluminum wires, each containing 4 Majorana particles. These structures can be connected like Lego, a genius move that makes scalability possible. Of course, there are still obstacles. The chip must run at temperatures colder than in space, which requires expensive cooling systems, and integration with classical computers and AI is a monumental task. But Microsoft is optimistic, and for good reason. They're already working on the next generation, and with each step, we get closer to a scalable quantum computer. Imagine, in a few years, you'll be sitting in front of a laptop that, with Majorana technology, solves problems that seem unimaginable today. We're standing on the brink of a new era. Majorana 1 is more than a chip. It's a promise that we can break the boundaries of what's possible. What do you think? How will it change our world? Let's write it together in the comments. If you like this update, give it a thumbs up and subscribe to the channel. And if you activate the bell, you'll be notified when we upload a new video. Hope to see you next time. Until then, stay real.